about what is actually complexity. And now we're moving away from the house example. So what would you understand by complexity if you say it's complex? And this is one way how you could tackle this. And I think it's a very easy and convenient way how to describe how complex a system is, or a thing, an object. I'll talk about systems, because systems are often what we model in IT. So we often model systems, something that does something. It could be a software program, could be a database system that we're modeling, and now we talk about objects or systems. So what makes it complex? And what makes anything complex?
I think that the number of things in the system makes it complex. The relationship between the systems and makes it complex. So not the number and not how big a system is. The number of relationships between the things in the system.
Okay, so you said that not just the number of parts of a system make it complicated, but it's more about the interactions of the different parts of the system. That's what you said. Okay, so and this is this is exactly the point that we're trying to make here, because when you have a system with a lot of parts, millions of parts, but they all do the same thing, and they are basically they all, in this case, they're all connected in a straight line, the one on the left, and everyone maybe does a similar thing, then it's very easy to describe what this model, the system does. So it's going to take us only a few short sentences to describe what the left system does. But on the other hand, the one on the right has, and there's another factor that comes in, it has a lot of different parts, and this is depicted by different colors and shapes. So if you have different parts and they're not all the same, but maybe fewer, and you have interactions between those parts, but different interactions. So maybe you have the dotted arrow here, then you have a green dotted arrow, a light green one, and so that this should indicate different interactions. So different interdependencies between those parts, it makes it very complex to communicate. So how would you describe how this system on the right works? It's going to take a lot more sentences than the one on the left. So just think about how you would convey this information to someone else. And this is basically true about a house that we're going to build. So if we wanted verbally to describe where all the walls sit and how large they are, it's first of all, it's very hard to do verbally. Second of all, it's very hard to understand for someone who tries to understand it. So we need, in this case, we need a visual representation, a visual model of the walls and windows and doors and stuff like that. So the reason why we need models is exactly for that reason, because we want to communicate complex stuff, and it's often very hard to communicate the working or the functionality of complex systems if they involve different parts and different interactions between those parts.